So, greetings of the day. On this day, in this video, you will be learning mobile app development, native versus cross-platform, and mobile landscape overview. So, let us start this particular presentation. So, in this course or in this video, you will learn mobile app development overview, mobile app categories, native app development overview, native app advantages, native app disadvantages, cross-platform app development overview, cross-platform advantages, cross-platform disadvantages, native versus cross-platform comparison, and mobile landscape overview altogether. So mobile app development. So generally we will be creating enormous number of applications. These applications will be installed in your mobile phone or maybe in a tablet, and these will be used for as per your requirement. So we have the types like native, cross-platform, and web-based. So mobile app development is the process of creating a software applications that run on mobile devices and use network connections. So to interact with remote computing resources, we have these three types: native, cross-platform, and web-based. So native apps are built on a specific operating system or a hardware device like Android, iOS, etc. So cross-platform apps are based on multiple platforms. They are intended to design on multiple platforms, not a single one. But there are some advantages, some disadvantages. We'll see that later. So we also have web apps. So web apps are specifically browser-based. Now, a browser may have HTML5 version or the previous ones, and we may also design a responsive web page. So coming to the essentials for business, so mobile apps are designed for business purpose, for education purpose, for entertainment purpose, and the daily life usage. So these are driven by growing mobile usage and digital transformation. So over 6.9 billion smartphone users are available worldwide nowadays. So they are using mobile apps that drive e-commerce websites, education, healthcare, etc. So let us see the example how these mobile apps are implemented. So one is we are having an app store. So this is one example of app store where you search the app and you install it or open it. Then we have one more example is our Google Play Store. So where we are going to install the apps that are required and use them as per our requirement. If any app is not there in these two, then it means that it is not having some standard that is required. That may be a voluminous one or a suspicious one, which may have some norm that is not satisfying these two, or there may be some specific reason, and they are not that much secure even. The only apps that are considered to be secured are downloaded from App Store or Play Store. So mobile app categories, we have native apps like platform specific, that is iOS and Android. They are developed for one platform only to access to device hardware like GPS, maybe camera. So for example, we are having WhatsApp, Instagram. So these are native app related applications. Coming to cross-platform apps, they are single code base for multiple platforms, means written once and compiled for many platforms. For example, we have Gmail, we have web dot WhatsApp, or it may be considered as a Google Docs. Google Docs is one example of web apps. Sorry. So we are talking about cross-platform. Coming to cross-platform, we have the examples of Airbnb or Uber or some other website. So web apps are browser-based. Without installation, they can run anywhere. They are responsive pages like Gmail Web or Google Docs, etc. So why we require these three are simply based on the required ones. by the client or the companies who are shifting from web apps to native apps. And over time, it is going to provide us the performance and various offline features. So coming to native app development, so it is built specifically for iOS or Android specific devices. So we may use the languages like Swift, Objective-C for iOS, or Kotlin or Java for Android. We have IDEs like Xcode for iOS, Android Studio for designing Android applications. There will be an app lifetime or life cycle, like we design, then code, then test, then deploy and maintain. Okay, so that is considered as app life cycle. We have SDKs along with this and APIs that provide native access to device components like cameras, GPS, microphone, maybe thumb impression, etc. So the advantages with respect to this particular slide are we have high speed, low latency, and better memory management. High speed, latency, and better memory management. So, for example, which kind of apps it may design for native app development are gaming apps like PUBG, very famous one, or Call of Duty. This requires native development for performance because we require a lot of graphics there. So the next one is native app advantages. We have high performance and speed. When we compile the code, it executes faster than when we interpret it or web-based applications. They take some time. So coming to the security, so we use sandboxing and encryption, which is better to handling native SDKs. We have UI and UX, which is a consistent one that matches platforms and guidelines like material design, human interface guidelines, etc. So coming to hardware access, we have cameras, biometric sensors, and NFC works that seamlessly works on the mobile devices. And offline functionality like no dependency on the network is one among them. So generally, if you consider an example, a banking application which is built natively for handling or curbing the security issues and offline OTP support is also provided is an example for native app advantages. If we see the disadvantages, we have a higher development cost. So we need separate teams for iOS and separate team for Android application when we design it. Okay. So there may be a time constraint, which is parallel development and testing, double the efforts are required. So coming to maintenance, we need to update the requirement in two different deployments, that is Android as well as iOS. So we require a lot of skilled people. So skilled people are required, need specialized developers for each language. And we may have some case examples also, a startup developing for Android, first to save resources, then porting it to iOS after funding, etc., etc. So the main question is when it is worth paying for a native app instead of using a Flutter kind of thing. So that is the main when we deal with the disadvantages of native APIs. Instead of using native API, can we go with Flutter? Okay, that is the one which we need to answer. So cross-platform app development overview. So we are having some key concepts here. That is write once, deploy anywhere. This is the main thing that we want. Write once, deploy anywhere. It uses shared code base that translates to native components. Shared code base translates to native components. So we are having some popular frameworks. One among them is Flutter, which is designed by Google or developed by Google. So it performs a Dart language. It uses a language called as Dart language. It is having widgets for consistent UI, user interface. We also have React Native UI. React Native is a meta kind of framework, which is having JavaScript with a React-based syntax. And we are having Xamarin, which is a Microsoft-based one. It is having the languages like C# with .NET integration. For example, if you consider Facebook is one among them, Airbnb is another one, Google ADS is one, Skype is another one. So these are some of the examples of our cross-platform framework implementations. So there is a concept called as hot reload in Flutter that speeds up the testing process. So what is this hot reload in Flutter? So hot reload is one of the Flutter's most powerful feature. It allows developers to instantly see the effect of the code change. Whenever you change the code, that code change has to be reflected on the app. So how it works? Flutter keeps the current app state in the memory and injects the updated source code files into the running Dart virtual machine. There is something called as Dart virtual machine in Flutter. So whatever the modifications you have done will be loaded onto Dart virtual machine. Once the VM updates the classes and methods, the framework rebuilds only the change widgets, not the entire widgets or the app entirely. It only modifies or rebuilds the updated widget in that particular application, and it takes hardly milliseconds. So speed is one of the benefit when we develop and debug using that is Flutter framework. It preserves the current UI state. You don't have to navigate back to some screen or etc. etc. Simply it is going to update all of a sudden without refreshing the screen even. So it encourages experimentation and rapid prototyping. That is one advantage. So for example, if you change a button color, then it all of a sudden it is seen on the emulator or the phone that you execute. So in order to do this, you have to do hot reloading. Hot reloading means nothing but pressing Control S. Control S is for save in most of the applications. So that is called as hot reload example. So let's go to the next slide. Cross-platform advantages. So the main advantage over here is speed. Okay, faster deployment. So 40% faster the native due to code reuse. It will be 40% faster. Cost reduction is one among them. To lower the cost, one team can manage multiple platforms. We need not have a separate team for native application like iOS or one separate team for Android. So that concept will not be here. So easy of maintenance. So single update will roll out all the devices. We don't need to modify two different applications. Unified UI. So we have consistent design across Android and iOS. So we have a broader reach, ideal for early stage startups and prototyping. So one example is e-commerce app like AliExpress is one example. So it uses React Native for multi-market reach. There is a concept called as multi-market reach. In order to use that, so AliExpress is using React Native API. Let us go to the next one. Cross-platform disadvantages. So there are a few limitations like slightly lower performance than native apps. So in order to build the communication, it creates latency. So that is the only thing. Limited API access. So new OS features take time to support. UI challenges, it is going to slightly, there are differences in look and feel, the cross-platform applications. Next one is plugin dependencies. We have third-party libraries may be unstable sometimes, so that may be an issue. So we have some examples like gaming apps. When we use cross-platform, there may be an issue with frame rate. That is called as frame rate sensitivity. That might be there. So let us move to the next slide. We have native versus cross-platform comparison. So native versus cross-platform, we have high performance in native, low moderate in cross-platform, cost is high, cost is lower in cross-platform, development type is longer, because for each and every API, native API, we have to design the software or app. And it is faster in cross-platform. Maintenance is complex in native, easier in cross-platform. So we need to have a platform separate one for iOS, separate for Android and other frameworks. Whereas coming to cross-platform, we have multiple platforms. Let us move to the next slide. Mobile landscape overview. When we deal with operating system, which is shared, we have Android, iOS, and others. Okay, like KIOS, Harmony OS, etc. Many OSs are there. I'm just taking limited ones. So to understand the business ecosystem around the app development is the main functionality of this particular slide. So when we have a market share, Android versus iOS dominance is there. Android is going to dominate. So Android is having a lot of market share when compared with iOS. Dominance is there. So main revenue of the channels is done through app stores. So there is a time spent on the engagement of the user on the different iOS and etc. devices. There is a issue with key dimension. So behavior analysis has to be performed. So modern frameworks are also there more with respect to the technology stack is concerned with Android than the other ones. So few challenges are there. Fragmentation and security is one more challenge in Android, whereas security is more in iOS and other devices. So when we consider Android is having 72 to 75% of the market, global market share, whereas iOS is having only 24 to 27%, which is more dominant in North America as well as in Europe. Okay. So other OSs are negligible like Harmony OS or Kai OS. So when we try to discuss this kind of thing, the developers often launch an Android first application, which is wider use base because of that reason. Then they shift to iOS. So because Android dominates the global smartphone market, especially in developing countries like India, Brazil, and Indonesia, launching an Android first allows developers to reach to more users quickly, gathering the feedback and validating the app idea with a rare and diverse audience. So it helps in testing the apps, the main thing, and the performance also under various circumstances, versions, devices, conditions, different screen sizes may be there, brands may be there, and OS versions may be there. So there will be a lower entry barrier might be there. So a Google Play Store has favor restrictions and lower app submission fee. One-time charge may be around $25, I think so, which is compared to Apple, it is around $99 annually for the developer fee. So app approval on Android is faster and less stricter, enabling quicker release of the particular update. So Android supports a wide range of devices, making it easier for independent or small developers to experiment and deploy the apps without high hardware cost. So Android is open source, in other words. It is going to have a nature that allows greater customization as well as the flexibility is considered when we design the app and its functionality too. So developers can integrate external libraries, modify the system level components, and experiment with innovation by adding more freely features or free features that exist. So that's why Android is dominating the other operating systems. So app distribution platforms. So we have a Google Play Store for Android, Apple App Store for iOS. Alternate stores are there like Samsung Galaxy Store, Hawaii App Gallery, Amazon App Store, and many are. So when you see a Google Play Store, it is an open ecosystem easily used by for publishing the apps. There are millions of apps exist. Coming to Apple App Store, it is strict review policies there. Quality of control is being maintained. Higher revenue per user is also there. So alternatives like Samsung Galaxy Store, Hawaii App, Amazon App Store, so different case studies are there. Let us take the example of one Udan App Store. Udan app that was designed for Indian users. So what happened is when Udan was launched in India, which is the largest business to business model, which is having an e-commerce platform, it connected retailers, wholesalers, and manufacturers across different sectors such as electronics, fashion, and groceries. It enabled small business like MSMEs have been integrated into Udan to buy and sell the products online efficiently. The issue that raised was Play Store billing policy. Like Google has requested or required that all in-app digital goods and services payments have to be made. So on Android apps, it is easy for Google Play billing system, GPBS, Google Play billing system. So this policy ensures Google receives a service fee typically around 15 to 30% of the transaction cost. 15 to 30% of the transaction cost. So apps that bypass this system by using external payment gateways like Razorpay, Paytm, or direct bank apps or UPI violate the Play Store terms. So what happened with Udan is Udan initially used its own payment mechanism for business transactions between sellers as well as buyers, where Google enforced the stricter policy. Store billing rules have been imposed. Udan was requested or required to shift its app payment model to company or comply that Google payment process. To avoid disruption, Udan temporarily made its app unavailable on the App Store, on the Play Store, and guided users to download its APK directly from the website. Later, Udaan got negotiated with the compliance and adjustment and updated its payment process to align with the Play Store policy. Now, Udaan is following Play Store policy, but there was a risk involved for a specific amount of time. The Udaan case highlights the challenges of digital platform dependency. So even larger Indian startups must comply with the global marketplace policies, emphasizing the importance of the policy compliance, payment transparency, and strategic flexibility. So the app development and deployment is not an easy task. We have to consider all this. So the next one is user behavior and trends. So mobile user spends 90% or more of time on the apps versus mobile web page. So the screen time of the apps is more in this context. So the top categories like social media, 25% of the time. Gaming is implemented for 20% of the time. E-commerce website occupy 15% of the time. And streaming is going to consider around 12% of time, app time or face time, whatever you call. So we have emerging trends. AI personalization, like Netflix has recommendations. AR/VR is having snapshot filters. IKEA Place, 5G and IoT. When we deal with the 5G and IoT, low latency apps like telemedicine and cloud gaming are there. So fintech is having digital wallets and UPI apps. So you can poll among yourself what are the apps that you have used and how the behavior of the apps is when making the digital payments or using digital wallets, gaming with IoT or medicine fields, etc. Let us move to the next one. So technology landscape, this is another thing where we have the frameworks and tools like Flutter, React Native, Swift, Kotlin, etc. So the backend is mainly the cloud-based, which is Firebase or AWS Amplify. So we have IoT integration with this one where we have the smart control, smart home control apps. We have wearable devices like fitness trackers, syncing with the mobile phones. We have AI backends, bots, and we have voice assistants are there. Instructor examples are there which demonstrate Firebase console. We can see that Firebase console just later on, where we can go to console.firebase.google, where we can create a Firebase project that we'll see in the coming classes or coming video. So the key challenges are we'll need to do device fragmentation, especially on the Android. Thousands of Android models are there which are tested on daily basis or hourly basis, which is a difficult task. Security and privacy is another thing. So there are data breaches, malwares are there, permissions abuse is there. So all this must be considered. Performance optimization is there, like battery usage and network constraints are to be considered. So we have App Store policy that is consistently changing with respect to the compliance rules are considered. User retention is the main churn rate that is due to competition. Okay. So we can discuss many things like breaches like Cam Scanner is one example, which is banned from Play Store from malware as a real world example. If considered in India, it is almost banned. Almost not everything. Cam Scanner is banned in India. So what happened is Cam Scanner is developed by Chinese company. It was widely used PDF scanning app with over 100 million downloads on the Google Play Store. But what happened is in August 2019, Google removed Cam Scanner after researchers from Casper Skylab discovered that on one of its recent app update included malicious code. The malware was a Trojan dropper. So what it has done is it has embedded with a third-party advertising library, which is used by the app. Once it is installed, it could download and execute other malicious modules. So it is potentially leading to unauthorized access, intrusive ads, even data theft is also found. So these are some of the key challenges that can be strict when we deal with iOS and somewhat naggy when we deal with iOS, but authorities are facing many challenges. So that's in this video. If you wrap up the summary of this video, we have seen a native app, which is performance and security based. Cross-platform is one more for dealing with speed and cost and efficiency of the app. The choice depends on the project goal, budget, and the audience who are using that app. So the questions may arise with respect to this particular class or session. Which framework would you choose for a college attendance app and why? You can answer that in comments. How can cross-platform development be optimized for security? So you are encouraged to do experiment with React Native and Flutter through a simple lab assignment like Hello World app or Android emulator to implement this. So you can answer these questions in the comments. That is, which framework would you choose for a college attendance app and why? The other one is, how can cross-platform development be optimized for security? So that's it in this video. Have a great day ahead.